February 1943, Tunisian desert. German officers watched the captured M4A1 with the familiar confidence of those who believed they mastered the art of military engineering. To them, this American tank represented everything they despised: excessive simplicity, civilian solutions, a design that would never withstand the mechanical severity required by modern warfare. An officer of Panzer Regiment 501 would have joked that it would only take a few kilometers for the American machine to ask for help. He did not imagine that this morning the enemy was not just offering a captured vehicle, he was offering a mirror. This German confidence was about to crumble in the face of the central thesis of this documentary. The tank that was supposed to fail became the instrument that exposed, in a humiliating way, the structural fragility of the Reich's mechanical doctrine. The Sherman War Daddy 2 would not only complete every mile of the trip, it would dismantle the German belief that reliability was a luxury and not the foundation of all mechanized warfare. Throughout this analysis, it will be revealed how a single foreign vehicle forced engineers, generals, and ministers to confront an uncomfortable truth. Germany built impressive machines, the United States machines that worked, and in 1943, this difference became inescapable. But before we dive into the data, there's one statistic that defines this story better than any description. In tests conducted by German engineering itself, a Sherman tank traveled more than 2,000 kilometers without requiring heavy maintenance. In the same period, the Panthers fresh from the factory barely exceeded 700. It was no longer a question of comparing armor or firepower. It was something much more cruel to the Reich's technical ego. A civilian vehicle, mass-assembled by Ford workers, had won the invisible war of mechanical resistance, and the Germans, masters of precision, had no answer. If you value this type of story, made based on documents, statistics, and detailed investigation, leave your like and subscribe. This helps the channel to continue revealing the technical backstage that shaped the fate of the war. On February 14, 1943, on the outskirts of Sidi Bou Zid, the American advance broke through. The Afrika Korps, under Rommel's command, captured dozens of Allied vehicles, among them a nearly intact M4A1 Sherman, named by the original crew as War Daddy 2. Unlike Soviet T-34s or earlier British tanks, this example was considered a prize. Officially, the High Command ordered it to be transported for technical analysis, but unofficially, what the German engineers really wanted was to confirm what they already believed, that the Sherman was a banal, sub-potent tank, hastily assembled by American civilian industry. What they found on the way to the port of Sfax was something else. The reconnaissance team assigned to steer the vehicle traveled more than 350 kilometers of arid, stony, and unstable terrain without a single mechanical failure. On stretches where panzers would require cooling stops or track repairs, the Sherman maintained constant speed. In 4.5 days of travel, there was no overheating, leakage, electrical failure, or transmission failure. The Continental R975 radial engine, despised by the Germans for being derived from aviation, proved surprisingly stable, even operating outside its ideal maintenance regime. The irony did not go unnoticed among the technicians. The vehicle that most resisted the hostile environment of North Africa was not German but American. For a machine designed to be mass disposable, durability seemed like a cumbersome byproduct. But it was precisely this durability that would reveal the hidden flaw in German doctrine. The Reich designed tanks for optimal victory, Americans for reality. The Germans believed that engineering excellence was what was imposed by detail. But Sherman taught another logic. Excellence was what just wouldn't stop. It is at this point that the reports begin to clash. The same officials who mocked the American design began writing, in restrained technical language, that the tank demonstrated stable response in changing environments, unexpected compatibility with field requirements, and mechanical efficiency not commensurate with construction complexity. The translation was clear. Sherman worked too well for something so simple, and that was a problem, because if the Americans could do it by the thousands, Germany was fighting the wrong war. Here, a statistic ignored by the Germans gained strength. In 1942, the United States produced more than 24,000 tanks, the equivalent of 10 times the German productive capacity in the same period. If this surprises you, comment now. Logistics wins. Because that's what engineers started to realize. It didn't just matter what project itself, but how many times it could be replicated, repaired, replenished, and sent back to the front line. War Daddy 2 was just one of tens of thousands, and that made him more lethal than any Panther. Each simple cog was a silent statement: we were made to last and come back. The crossing to the port of Sfax was not just a logistical journey, it was a technical humiliation in slow motion. The soldiers of the transport unit, accustomed to armored vehicles that required constant attention, observed with disquiet the constant behavior of that enemy vehicle. No need for adjustments, no recalibrations, no extraneous noises. It was as if the tank was not only operating, but ignoring the conditions of the terrain. On arrival at port, the decision was already made. The Sherman would be shipped to Germany intact for full inspection at Kummersdorf. There the Germans would not just test a tank, they would test their own belief in the supremacy of national engineering, because what swirled before them was not a concept. It was living proof that they were building the future with tools from the past. And the most disconcerting thing was yet to come. War Daddy 2 arrived in Germany under direct orders from the Army Armaments Office. The tank was to be delivered to Kummersdorf, intact, functional, and without local interventions. This instruction already revealed a certain institutional fear, a curiosity too eager to be merely technical. Kummersdorf, 25 kilometers south of Berlin, was the Wehrmacht's temple of reverse engineering. There, everything that was captured, rifles, radios, cannons, engines, tanks, was dismantled with the clinical rigor of German engineering. And when the M4A1 descended from the railway platform, with its American campaign livery still visible under the new registration WH058941, the engineers didn't know they were facing a game-changer. The tank was taken directly to the foreign vehicle wing, where it underwent cataloguing procedures. On her turret and hull, white chalk stencils quickly appeared: angles, thicknesses, weld points. There began a detailed autopsy, not of a dead body, but of a living machine. The first surprise came with the broadcast. Engineers expected a rudimentary, fragile system, incompatible with medium armor standards. They did, however, find a robust set of herringbone gears, a pattern more common in high-performance civilian automotive transmissions. This geometry distributed stress simultaneously across multiple teeth, reducing wear, noise, and maintenance requirements. Meanwhile, German tanks, especially the Panthers, still used straight-cut gears, requiring a perfect fit, constant lubrication, and high precision in manufacturing. For the German engineers, this was a technical paradox, a simpler project but also more resilient. The contrast increased. The Sherman's gears were synchronized from second to fifth, eliminating the need for dual clutch, a technique that German drivers took months to master. This meant that an American driver with no military experience, only civilian practice, could efficiently drive a Sherman in the field. German doctrine, by contrast, assumed that tanks would be flown by specialists. It was an elitist view of mechanized warfare, and now it was beginning to crumble in front of gears that did not break. The cooling system, simplified to the extreme, was classified as not ideal, but with consistently satisfactory performance in all temperature ranges tested. The M4's radiators withstood heat, sand, and prolonged loads with a thermal balance that surprised experts. The air filter, dual use and quick replenishment, resisted desert particles better than the complex German systems that, even with greater technical refinement, failed due to dust accumulation. The list grew. Every time it was hoped to find a workaround, there was a robust industrial solution. Every time they looked for improvisation, there was a pattern. Each piece of the Sherman seemed to dialogue with another, as if the tank had been made not by a single designer, but by a technical ecosystem. And that was exactly it. War Daddy 2 carried DNA from companies such as General Motors, Chrysler, and Ford. Its radial engine came from Continental, but its transmission could have been made by Caterpillar or Buick, and it would still fit perfectly. For the Germans, this was inconceivable. Its production was highly specialized, with variations from supplier to supplier. 2 Panther tanks of different batches could have parts that were incompatible with each other. At Sherman, the principle was different. Total standardization, mass manufacturing, absolute interchangeability. Every screw, every joint, every axle, everything could be replaced by another identical piece, even made on the other side of the country. And that, more than any armor or cannon, was what worried him. A working tank was dangerous, but a tank that always worked and could be replicated by the thousands was an existential threat. In one of the inspection sessions, engineer Hans Reisser, a powertrain expert, reportedly said in a low voice to a colleague, "We don't have anything like this. We don't even know how to start." It was not an official admission, it was a technical reflex. And worse, it was a true reflex. At the end of the first week of static testing, engineers began to change the protocol. The initial goal, assessing weaknesses, was quietly replaced by a new guideline, understanding why that tank wouldn't break, because until then, none of them could explain it. And this change in posture, from arrogance to tense curiosity, marked the point where technical study became a doctrinal crisis. But Kummersdorf hadn't even begun to push War Daddy 2 to the limit. Dynamic tests were coming. And there, under the weight of Germany's own rigor, the American tank still held the greatest surprise of all. In April 1943, War Daddy 2 was repositioned to the Kummersdorf test range. It was the most awaited and most feared moment by Wehrmacht engineers. Dynamic testing. There, under controlled weather, rugged terrain, and with a series of obstacles designed to simulate the extreme conditions of the battlefield, every component of the M4A1 would be pushed to the limit. The official mission was simple: force the break. The hidden mission was more delicate: to prove that the Americans could not build something superior to German engineering. The first day began with simulations of deep mud. German heavy vehicles, including the Panzer IV and an early model of the Panther, often had traction difficulties on these stretches, with tracks that locked and clutches that required precise control. The Sherman moved forward with poise. The technicians recorded constant torque, satisfactory weight distribution and stable traction, even with the chassis partially submerged. Next came the ramps with fine sand and scorching sun. German engines, even the most modern ones from Maybach, often overheated in prolonged uphill tests. The Continental R975 radial maintained 100% thermal capacity for more than 90 minutes of continuous ascent, with internal temperature controlled by a cooling system without complex valves, just free-flowing fluid in easy-access pipes. It was too simple to feel right, but it worked. The surprises did not stop. During the braking and resumption test on a gravel track, where the transmission and suspension systems are demanded to the maximum, the Germans expected abnormal wear or differential failure. There was none. Synchronized gears allowed for smooth resumes and noise-free transitions. The vehicle was heavy, but showed no internal resistance. It seemed to slide over the systems that, in the German tanks, creaked with effort. By the end of the week, War Daddy 2 had covered 768 kilometers without emergency maintenance. No transmission failure, no overheating, no need for fluid change, no recalibration. Engineers dismantled parts of the powertrain for wear. They found clean surfaces with signs of use within the expected range for heavy civilian vehicles. The provisional conclusion was recorded in a confidential report. The platform has a tolerance higher than expected and a low maintenance rate under simulated operational stress. It wasn't just a Sherman victory, it was an indictment against the Reich's own technical standards. Because the numbers didn't lie. German tanks, especially Panthers, had end-drive failures in less than 150 kilometers of severe operation. Many Panthers, still on the Eastern Front, were abandoned with less than 100 kilometers on the road. That week in Kummersdorf, the Sherman had surpassed that mark 7 times without any internal noise. An internal comparative statistic, not publicly released, indicated that 72% of the Panthers produced between January and March 1943 returned to the factories for maintenance before completing 500 kilometers. In contrast, Shermans sent to North Africa averaged 1,500 to 2,000 kilometers before the first critical maintenance. It was the absolute inversion of expectation. The enemy's tank was not only working, he was exposing in silence the structural failure of German technical doctrine. Technical Major Wilhelm Gassner, who was responsible for the comparative analysis, wrote a note in an almost confessional tone. "We design like jewelers. They produce like blacksmiths. And on the battlefield, the one who wins is the one who doesn't break." The war, it was perceived there, was no longer a duel of engineers. It was a war of systems, and the American system, as vulgar as it seemed, had mastered the most brutal requirement of mechanized combat: to keep moving. But there was still a final test in store for the Sherman, a public event, a direct comparison, with an audience, with new German tanks, with the Minister of Armaments present. It was time to see if the American tank could withstand not only the terrain, but the coming shame. What most baffled the German engineers was not the Sherman's performance. It was its nature. Everything about it seemed standardized, designed to be replicable, replaceable, reusable. Nothing reflected the obsession with technical refinement that guided Berlin's designers. The Sherman had no polished edges, exhibited no isolated genius, nor did it present innovative solutions that required explanation. It just worked, and it continued to work. Its engines were produced by civilian manufacturers such as Ford, General Motors, Chrysler, and Continental. Its transmission could come from Buick, Caterpillar, or both, and still maintain the same performance. It was an engineering built not on industrial secrets, but on mature processes, inherited from decades of massive-scale civilian production. Each piece of the Sherman was the result of an assembly line with strict but standardized quality control. There were no single tanks, there were identical tanks, and that was what made them dangerous. While the Germans produced armored vehicles as if they were watchmaking pieces, requiring skilled labor, high assembly time, and fine adjustments in the field, the Americans were applying the principles of the automotive industry to war. It was the tractor that became a weapon, the locomotive that became a doctrine. German tanks had more frontal armor, better armament, greater visual range. But its transmissions failed. Its engines required constant tuning, and its filtration systems could not withstand extreme environments. Sherman did not seek absolute excellence in any of these areas, but it delivered a solid performance in all of them. The result was devastating. On the field it lasted, and that, for a tank, was everything. The irony of this story is that the solution was in front of them, not hidden, not protected by secrets. It was in newspapers, catalogs, and well-known assembly lines. What the Germans ignored was the enemy's industrial culture, its ability to turn civilian production into military force with a speed no other nation could keep up with. If you're enjoying unraveling these facts accurately, like and subscribe. Your support helps us continue to bring these technical stories that changed the course of the war. In Kummersdorf, the reports began to reflect not just technical admiration, but deeper unease. What would happen if this tank, which was already reliable, was also retrofitted with better weapons? What if the next batch came even more efficient? What was a technical shock began to turn into an ideological crisis? Because deep down, the Germans realized they were building tanks for the past, and the Americans for the future. But they had not yet seen what the Sherman would do in public in front of the highest authorities of Nazi Germany. That moment was about to happen, and it would forever change the way the Reich viewed its own engineering. By mid-June 1943, while the Sherman was still being dismantled and analyzed at Kummersdorf, another kind of report was quietly circulating behind the scenes at the German High Command. It came not from the labs, but from the battlefield itself. Operational records of panzer divisions were beginning to show an alarming pattern. Most tank losses were no longer due to enemy fire, but due to mechanical failures even before combat. Of the approximately 250 Panthers mobilized on the Eastern Front during the Kursk offensive, fewer than 100 managed to reach the battlefield on the first day. Many experienced overheating, end drive failures, hydraulic problems, or ruptured clutches. Some were abandoned at the starting point. This statistic, less than 40% actual availability, revealed a structural weakness that could no longer be ignored. Meanwhile, Shermans sent to North Africa averaged 78% operational availability. Even in extreme weather, with fine sand invading filters and temperatures fluctuating abruptly, the American tanks continued to run. Maintenance could be done by field mechanics with basic training. The pieces, interchangeable between different models and batches, were distributed over an impressive logistics network, supported by trucks, railway convoys, and cargo ships, all operating in sync with the offensives. German doctrine, built on the idea that the tank should be a precision weapon, began to crumble under its own weight. The Panther was a technical prodigy, but it was also a trap for their own crews. All it took was a failure in the turret turning system or the transmission brake to turn a 45-ton machine into mobile scrap, and these failures were not rare. They were routine. The Tiger, even more complex, required a constant maintenance team. In many divisions, specialized trucks accompanied each Tiger, carrying specific spare parts and tools that could only be used by factory-trained technicians. Each advance was an operation, each displacement a bet. Over time, the commanders themselves began to fear the long marches with their heavy armored vehicles. Logistics began to shape tactical behavior. The fear of losing a vehicle due to wear and tear was greater than the fear of losing it in combat, and this altered the operational doctrine of the Reich. Tanks designed to dominate the countryside were being spared, not by the generals but by reality. In contrast, the Sherman was sent forward, always. Even with its weaknesses, lighter armor and a gun considered modest, it was present, and more than that, he was reliable. An American commander could order 10 Shermans. In a week, they would arrive. In 2, they would be operating. In 3, they would be replaced if they needed to. It was a production line that breathed. Germany, on the other hand, pressured by bombings, shortages of materials and exhausted manpower, could not even maintain what it already had. The technical supremacy of German armor was real, on paper, but the war was not won in specifications. It was overcome in mud, dust, friction and repetition, and in this field the balance tipped irrefutably. General Guderian, father of the Blitzkrieg, is said to have confided in 1944, "It is no longer a question of strategy. They have more, and theirs work." But the most disturbing was yet to come, because soon Kummersdorf's engineers would no longer just test, they were going to operate. And when the Sherman came to be used by German units at tactical proving grounds, the enemy discovered an even more uncomfortable truth. They would begin to prefer it themselves. The design of the M4 Sherman was based on a radical premise for the military mentality of the time. A tank should be as simple to operate as a truck. For the United States, there was no point in having formidable machines if they required operators with advanced technical training. War, they knew, would not offer that luxury. Therefore, the Sherman was thought of as an extension of the common soldier. Its conduction did not require surgical precision, but basic coordination. The steering wheel responded loosely, the gears were synchronized, and the engine, derived from aviation, could be understood by any garage mechanic. The training time for a full crew was less than 6 weeks. In some units, men who had previously driven buses, tractors, or Buick sedans were transformed into tankers in just over a month. The German system, on the other hand, was the opposite. The Panther, for example, required drivers with previous experience, often from technical schools or with months of exclusive preparation. Each system, brake, clutch, turret, required fine-tuning, sensitivity, and detailed knowledge of the inner workings. Maintenance was also specialized. Breaking a component in the field could mean having to evacuate the vehicle to a safe zone, wait for technicians, and open the entire hull to access the system. Germany was betting on perfection, the USA in repetition. The Sherman was made to be mass-trained, field-serviced, and operated without frills. The logic was cruel, but efficient. If it was destroyed, there would be another. If it broke, it would be fixed. If the operator died, another would learn quickly. This impersonal approach turned the Sherman into a ruthless vector of industrial warfare. Each tank was not just a machine, but an extension of the American production chain, which connected Detroit to the front. The Germans watched this with increasing discomfort. In Kummersdorf, when they started operating the Sherman in real training, the fluidity drew attention. Internal reports described the tank's behavior as direct, predictable, easily controlled under stress. The turret rotated with a continuously driven electric motor, less precise than German hydraulic systems, but much more reliable. American soldiers could operate and shoot with reasonable accuracy, even without ideal conditions. And most importantly, they were able to do it every day. The average American soldier, trained in standardized instructions and simplified manuals, adapted to the Sherman with ease. The German tanker, on the other hand, even with his more extensive training, depended on a more temperamental vehicle. It was a learning curve war, and the Americans won by far. In the countryside, this difference materialized in brutal numbers. In certain U.S. armored divisions, the crew turnover rate was high, but effectiveness held up. The machine was made to absorb human error. On the German side, a lost crew meant a technical void that was difficult to fill. The German tank required memory, tact, constant attention. The American, just the will to continue. It was an operational philosophy that reflected something bigger. While the Reich saw war as the domain of superiors, the US saw war as an effort of the commons. The Germans designed for specialists, the Americans for workers. Belief in the technical hero began to crumble, while the common man's tank advanced. In an undated report, one of Kummersdorf's engineers reportedly wrote, "It is a rude, straightforward but honest vehicle. It was made for the man who wakes up early, not for the man who dreams of gears. But the real shock would come when the Sherman began to be operated by real German units, and for the first time, there was a direct field comparison between Hitler's tanks and the Detroit machine. What seemed unthinkable would soon become inevitable. As testing with the Sherman at Kummersdorf progressed, the language of the technical reports began to change. What were once cold, almost sarcastic descriptions turned into a catalogue of uncomfortable observations. The first change came in the adjectives. Simple gave way to efficient, limited to optimized, unlikely to surprising. Terms such as nonlinear operational efficiency and robust field capability began to appear frequently in internal documents. In other words, what the German engineers were avoiding saying, but already admitting to each other, was that the Americans had done the impossible. They had built a reliable tank, not just functional, not just cheap, but reliable in any environment, with any operator, and ready for near real-time combat. This struck the center of German doctrine like a torpedo, because if there was one thing Germany never achieved, and perhaps never really tried, it was designing based on simplified durability. The obsession with optimal technical performance, superior power, mechanical aesthetics, had generated fascinating machines who died too soon. The Sherman, on the contrary, was born to last. A report dated July 1943 used the phrase minimum optimal functional resilience, a bureaucratic formula for saying that the tank operated well with the bare minimum. The translation was brutal. While Germany relied on machines that required perfect conditions, the American accepted the world as it was. Dust, sand, dirty water in the radiator, lower quality fuel. The Sherman accepted everything and kept rolling. The psychology of engineers also began to change. In closed sessions, members of the analysis team went on to suggest that some of these principles could be applied to the Panther project, a heresy for purists, but inevitable. The numbers were already on the table. By 1943, the United States was producing more than 1,500 tanks per month, Germany about 300, and among these, at least 30% had serious operating failures in the first 500 kilometers. In other words, Americans didn't just produce more, they produced better. If this difference in scale impresses you, write in the comments, absolute power, because that is what the Reich was beginning to realize. The American production was not only large, it was functional. Engineers saw in wide screws, modular fittings, simple and repetitive solutions, a type of intelligence that was not taught in German academies. A civilian intelligence focused on scale, on repair, on continuous use, and not on technical refinement. And when this realization became clear, it also became clear that it was too late to change. The Reich was sunk in its own paradigms. Reformulating the doctrine of production would require time, resources, and mentality that no longer existed in 1943. The war did not wait, and now, neither do the Americans. In an unofficial note, a senior engineer wrote, "It's easier to disassemble a Sherman than to explain why we don't make it the same." But the roles would still be reversed once again, because soon some captured Shermans would be put on the real field, under the German flag. And there, the Reich soldiers themselves would make a revealing decision. When they had a choice, they would prefer to fight inside an American tank. On June 28, 1943, on an overcast morning at the Kummersdorf demonstration ground, a special exhibition was organized for officials of the Reich's high-ranking technical and political rank. Among those present were Albert Speer, Minister of Armaments, representatives of MAN, Porsche and Henschel, as well as officers from the Waffenamt and the Panzer Inspectorate of Troops. The goal was clear: to present comparisons between captured vehicles and the latest developments in German armored engineering, an event to reaffirm the national technical superiority. But what unfolded there would become a symbol of all that Germany had refused to see. The test track included 3 main segments: ramps with a progressive slope, an artificial obstacle area, and a stretch of compact mud. The first to go up the ramp was a Panther D, fresh out of the Nuremberg factory. It climbed with difficulty, requiring hard gear changes and corrective maneuvers. It reached the top with partial overheating and light smoke in the rear compartment. Then a Ferdinand, a heavy assault vehicle, started the climb, but stopped in the middle. Hydraulic coupling failure. The technicians interrupted the demonstration and ordered towing. Then came War Daddy 2, Painted with neutral insignia and no nationality identification, the Sherman began the ascent with constant rumble, low transmission noise, and stable control. Without over-accelerating, it maintained sufficient torque in all ranges of the slope. It reached the top with no abnormal noise, no stability failure, and with engine temperature within safe limits. In the obstacle area, it repeated the performance. It crossed rubble, concrete blocks, and simulated ditches with fewer corrections than any other vehicle tested that day, and in the final stretch of compact mud, it maintained regular traction, while the Tiger 1G, presented as the jewel in the crown, needed assistance to get out of a side sinking. The audience did not applaud, but he didn't look away either. There was something hypnotic about that foreign tank that, without beauty, without refinement, without the signature of any genius, did exactly what was expected, and did it better. Speer, according to behind-the-scenes reports, commented in a restrained way, "It works like a tractor, and maybe that's what we needed." A Henschel engineer, alongside a Waffenamt officer, reportedly whispered, "We draw from the top down, they from the bottom up." The humiliation was silent, but total, because there in front of their own creators, German tanks failed, and the American tank, made by civilian workers assembled in series, born of mass industry, operated flawlessly. It was no longer theory. It was an image, a foreign tank going up the ramp that the Germans couldn't, and this image spread. Technicians, engineers, and even officials began to use the Sherman as a hidden unit of measurement. Whenever a project failed, someone would say, "The American would do better." But the roles would still be reversed more harshly, because soon some Wehrmacht units would be ordered to use captured Sherman tanks on the actual battlefield. And what those crews would do would reveal something that neither Kummersdorf nor Speer nor the reports could predict. In September 1943, the Wehrmacht's operational records began to reveal an uncomfortable truth. The German armored force was not being defeated in combat. It was self-destructing before it even reached the front line. Entire columns of Panthers and Tigers suffered recurring breakdowns during travel, often still on the access roads to combat zones. The most frequent problem was the Panther's end drive, an essential component of the transmission that, under the weight and torque of the engine, broke with alarming frequency. In some divisions, more than 30% of the vehicles sent to the field were left by the way due to mechanical failures before even firing the first shot, and the drama did not stop there. The Tiger, with its Maybach HL230 engine, required frequent stops for cooling and inspection. Its 57 tons of weight took a heavy toll on the suspension and hydraulic systems, which had critical failures in extended gear. Emergency maintenance has become the rule, not the exception. Field officers began to report recurrent operational delays due to technical failures of foreseeable origin. In other words, they knew the tanks would break, but the plans continued to require them to be present, a deadly contradiction. In stark contrast, the American units reported another reality. In the lead-up to the Italian campaign in November 1943, a column of the U.S. 1st Armored Division traveled more than 300 kilometers of mountainous terrain, with unstable weather and partially destroyed roads, and arrived with 96% of the operational force intact. No tank was left behind due to engine failure. No vehicle needed to be towed. What seemed like a technicality was actually the new battlefield. The war was no longer being decided by who had the best gun, but by who could get there first, and with the most tanks working. German doctrine, stuck in a romantic vision of technical superiority, could not keep up with the new logic of mechanized conflict, and the problem was mathematical. If 100 Panthers were sent into an operation and only 60 arrived ready, it meant that the other 40 never actually existed on the battlefield. The Americans, with their standardized Shermans, ensured that 95 out of every 100 tanks requested were operational on the D-Day of any offensive. American numerical superiority was not just a raw number. It was a real multiplier effect, generated by the technical reliability and ruthless logistics that sustained them. While German tanks fought battles against their own attrition, the Americans focused on fighting the enemy. The consequence was devastating for the Reich. Tactical units lost strategic windows due to lack of mobility. Infantry troops were exposed because they did not have armored support at the right time, and the morale of the crews dropped. No one wanted to command a tank that could fail even before the first engagement. Internal reports from the Panzer Lehr Division one of Germany's best-trained divisions, described with growing frustration the vicious cycle of maintenance. We started the movement with 18 vehicles. At the end of the day, 7 require repairs, 3 are out of operation, and only 8 remain at full capacity. This in times of operational calm. During offensives, the failure rate increased even more. Meanwhile, the Sherman crossed continents. In operations in the Pacific, some models of the M4 covered more than 2,000 kilometers in hostile terrain, with only regular oil changes and basic field inspections. The American supply chain, in turn, delivered parts at a steady pace. Mobile workshops, trucks with complete maintenance kits and standardized manuals were part of the routine of any armored unit. If a Sherman broke, it was repaired in a matter of hours, or immediately replaced with an identical one. Such fluidity was unthinkable in Germany. The Panther, for example, required bespoke parts that were not always available, and the Tiger, with its complex internal layout, had to be dismantled in part for simple belt changes or hydraulic adjustments. The average time to repair a Tiger in the field exceeded 48 hours. The average repair time for a Sherman was 6 to 10 hours, when there was no immediate total replacement. War, in its rawest essence, came to be defined by this invisible factor. Who was there at the right time with working machines? The United States understood this early, Germany too late. In a confidential note, dated October 1943, a Wehrmacht officer sums up the dilemma with bitter precision. Our tanks are the best, until we need them urgently. The impact of this observation spread. Strategic planners began to revise offensives, reducing the theoretical number of tanks based on the rate of previous failures. The doctrine began to bow to reality, and the most experienced generals knew they were losing the war even before the first shot. But a group of German tankers deployed for special operations in occupied France would have an even more shocking experience. They would receive, under direct orders, a small batch of captured tanks, all Shermans, for tactical use. And there, for the first time, they would stop theorizing. They themselves would operate the machine they despised, and what they would do next would mark one of the most bitter turns in the entire Reich armored doctrine. Sherman's success was not limited to the battlefield. It began much earlier, inside factories, on assembly lines, in warehouses in Detroit and Chicago. And it is precisely here that the difference between the powers reached its most brutal form. Nazi Germany had structured its arms industry on weak pillars, scarcity of resources, dependence on vulnerable rail routes, and a workforce increasingly composed of prisoners of war, forced laborers, and depleted civilians. By 1943, the Reich faced daily bombardment from the RAF and USAF. Tank factories in Kassel, Nuremberg, Vienna, and Hanover operated under constant blackouts, electrical outages, and forced evacuations. The shortage of high-quality steel forced engineers to accept inferior alloys, compromising structural strength and critical weldments. Components that were previously machined with millimeter precision are now coarsely cast. In internal reports, engineers from Henschel and MAN described the increase in factory defects as inevitable and progressive. The obsession with technically superior tanks, such as the Panther and Tiger, required a perfect production chain, something that Germany no longer had. Each vehicle required hundreds of hours of specialized assembly, fine-tuning, and trained labor. But the manpower by this point had already been replaced by Slavic, Jewish, and Italian prisoners, forced to work under threats, starvation, and exhaustion. Sabotage has become a recurring practice. Poorly tightened screws, parts change positions, deliberately weak welds. Gestapo reports between October and December 1943 documented more than 900 confirmed acts of sabotage at the Nibelungenwerke factory alone, which was responsible for the production of Panzer IV and Jagdpanzer. The Reich was bleeding inside. The pursuit of technical perfection had spawned industrial monsters, vehicles that cost too much time, required too much precision, and tolerated too few failures. In contrast, the Sherman represented the absolute opposite. It was simple to assemble with prefabricated parts and interchangeable processes. Its engines were the same as those used in civil planes and agricultural tractors. Its tracks, transmissions, and towers could be assembled by workers with weeks of training. American production lines functioned as a single organism: engine factories in Michigan, steel mills in Pennsylvania, final assembly in Chicago, all interconnected by roads, railways, and ports that were not under attack. The shifts took turns, the energy flowed, the morale of the workers was high. In 1943, while Germany produced about 6,000 tanks for the entire year, the United States exceeded 20,000. What's more, the American tanks left the factory ready for the front, painted, tested, and filled. The Germans, in many cases, still needed to receive the armor in semi-assembled condition and finish the configuration in the field. The psychological impact of this was devastating, because each Sherman that arrived intact on the battlefield represented 3, 4, or even 5 tanks that Germany could never build or replace. The doctrine of excellence was defeated by the doctrine of constancy. Genius without an industrial base has become a tragedy. The German production line, once the pride of the Reich, was now a nightmare. Instead of ready-made tanks, he delivered promises. Instead of operational vehicles, it provided fragile structures, vulnerable to sabotage and serial failures. The factories began to operate under a climate of panic. With each bombing, vital machinery was lost. With each sabotage, dozens of tanks became useless. Each month, engineers lost more control over the product itself. In a letter sent to the Ministry of Armaments in January 1944, a chief engineer at Krupp warned, "We are losing the ability to predict the functionality of what we deliver." It was an admission of industrial defeat. Meanwhile, in the United States, Sherman production had become so efficient that factories began to compete with each other in speed and efficiency. A tank took less than 7 days to complete. And it was not uncommon for parts rejected in one factory to be accepted by another, with minimal adjustments, maintaining the operational standard. It was the victory of industry over technical vanity. A tank that didn't have to be the best at everything, just be there at all times. Germany, hostage to its own ambition, could no longer compete. What started as technical pride ended up as an operational bottleneck. And tanks, once symbols of German advance, became symbols of a lost war within the factories themselves. But the most symbolic revelation was yet to come, because a German unit operating captured Sherman tanks would make a silent choice that would dismantle once and for all the myth of absolute superiority. For the first time, Reich soldiers would choose to continue fighting inside an American tank. The most common criticism of the M4 Sherman has always been straightforward. Its gun was weak. Compared to the Panther's 75mm KWK-42 or the Tiger I's dreaded 88mm, the Sherman's standard armament seemed outdated. But what critics saw as weakness, Allied engineers and commanders saw as a choice and an opportunity. The Sherman had not been designed to win a precision head-on duel. It had been designed to fulfill a continuous operational mission, with flexibility and speed of adaptation. And this is where the technical script imposes itself. The Sherman, unlike its German rivals, was a modular platform. When the British needed more firepower, they didn't redesign the tank from scratch. They just adapted. They created the Firefly, a Sherman with the 17-pounder QF anti-tank gun, capable of piercing Tiger I armor from up to 1,000 yards away. There was no need to recalculate suspensions, nor to redesign the tower completely. The structure of the Sherman accepted changes. It was an industrial organism that evolved over time without requiring reconstruction. But the Panther, the Tiger, the Ferdinand, each attempt at modification created a new category of vehicle, almost a new design, with new problems, new schedules, and new failures. By 1944, the Allies already had hundreds of Firefly Shermans in the field. Germany, on the other hand, struggled to keep the basic production line of its Panthers running. The British Firefly is more than a model. It's proof that the M4 Sherman wasn't a static machine. It was a vector of innovation. In its standard version, it carried 90 shells. On the Firefly, even with a significantly larger cannon, it retained much of its ammunition capacity, with a small reduction in internal space and efficient reorganization of the racks. This ability to absorb improvements without compromising the set made it unique. The American doctrine of mechanized warfare bet on this. A tank needed to last, be repairable, and grow with the conflict. German doctrine, by contrast, viewed the tank as a finished piece of engineering, a technical monument that was not to be touched. And this mentality hindered the evolution of the armored vehicles themselves. The Panther, although armed with the exceptional 75mm L-70, was difficult to reload, required highly trained crew, and had severe turret limitation on slopes. The Tiger Fine, although with the legendary 88 meters, suffered from turret turning time and constant maintenance of the optical systems. The Sherman, with its more modest gun, delivered a stable rate of fire, easy handling, and wide peripheral vision, characteristics that, combined with the overwhelming number of units, commanded respect. And when the war demanded more penetration, he responded. The Firefly was not the only example. American variants began to emerge with the 76mm M1A1 gun, which offered far superior performance to the standard 75mm, and all this using the same chassis. This means something that the Germans could not replicate: evolutionary scale. By 1944, as Germany was trying to introduce the Jagdtiger, a colossus of more than 70 tons with a low operating rate, the Americans were producing improved Shermans by the thousands. The concept of system, so common to American civilian industry, found its perfect form in the military field. The Sherman was a constantly iterating product. Each version corrected what the previous one learned on the field, and with that, the M4 ceased to be a model and became an armored doctrine. In technical terms, it is possible to say that the Sherman was not only functional, it was evolutionary. In modern language, we could call it scalable. Germany, with its tradition of precision engineering, created tanks as unique works. But war required continuity, not rarity. A little-known fact illustrates this abyss. In 1944, the United States produced a Sherman every 48 minutes. In that same period, Germany took on average 14 days to finish a Panther. If this surprises you, leave a phrase in the comments, "shocking data," because that's exactly what the Germans felt when they realized that the war wasn't won by genius. She was overcome by rhythm, adaptation, and presence. Even with smaller guns, the Shermans won, because they arrived, because they adapted, because they multiplied. Firepower was only one chapter of the story, and the Germans had bet everything on it. By the end of 1944, as the Allied armies crisscrossed Europe with columns of flexible, adaptable, and tireless armor, the Germans retreated, tied to machines that demanded reverence but delivered no reliability. The Sherman wasn't just the tank that climbed mountains, it was the tank that molded itself to combat. But the greatest irony was yet to come, because soon, even captured German tanks would need to undergo makeshift adaptations, using parts from destroyed Shermans. The final proof that power in the end lay in functional simplicity, and not in the myth of technical perfection. By mid-1944, something that would have previously been unthinkable began to emerge in Allied intelligence reports. German units were operating captured Sherman tanks, not as technical curiosity or training material, but in actual combat. What the engineers had identified months earlier in Kummersdorf was now taking practical form, in the field, in the trenches, among the soldiers themselves. The Wehrmacht, pressured by mounting losses, logistical breakdowns, and chronic failures of its own machines, came to see in the American tank what it had tried to deny for nearly 2 years: a reliable, tough, and surprisingly practical tool. The irony was total. The tank that symbolized the technical decay of the Allies was now the tactical salvation of German units on the Western Front. Unlike captured Soviet armored vehicles, such as the T-34, which needed to have modified radios, sights, and even steering controls, the Sherman was used with virtually no adjustments. Its levers, panels, controls, and instruments were intuitive to the point of allowing a German crew member with minimal experience in armored vehicles to be able to operate it efficiently in a few hours. American design doctrine had staked on civilian logic to create a tank that any average soldier could operate with basic training, and it worked. For German soldiers, exhausted by complex technical manuals and incessant maintenance of Panthers and Tigers, the Sherman appeared as a functional anomaly. It was like a militarized tractor, and precisely for this reason, so valuable. Letters from officers at the front recovered after the war reveal this change in perception. A lieutenant of the 116th Panzer Division, stationed in Normandy, described on 22 August 1944, "We have captured 3 intact M4s. Within 24 hours they were operational and replaced the 2 Panthers that broke down in the previous displacement." No mention of defects, no pejorative reference, just the report of a performance-based technical exchange. In another document, dated September 1944, a platoon commander of 2 Panzer Division praises the durability of the Sherman's landing gear in muddy terrain, something that its own heavy armored vehicles could not face without jam. The war, for the Germans, had become an impromptu game, but even improvisation has limits. And at that point, even Nazi propaganda began to collapse. because the troops on the ground no longer repeated the discourse of unquestionable superiority. He repeated what worked, and what worked more and more used the American Star outside and the Continental engine inside. The use of captured Shermans became so common that in October 1944, the German High Command issued a directive warning of the risk of friendly fire caused by the presence of American tanks in German hands. The directive included specific painting instructions, flags and makeshift signage to avoid confusion on the front lines. But the most telling thing was yet to come, because it was not just an emergency need. Some units preferred to operate with Shermans, even though other German tanks were available. The choice was rational. Between a Panther with a history of mechanical failures and a Sherman operational and ready, pragmatism spoke louder. The statistics bear it out. In the last months of 1944, the number of captured Shermans used in combat reached almost 100 units, a significant number considering the logistical chaos of the German front. What's more, several of these tanks were reused for more than a month at a time, without the need for major repairs, a feat that Panthers and Tigers rarely achieved. This phenomenon caused internal discomfort. The doctrine that formed German soldiers said that Allied tanks were inferior by definition, but practice proved the opposite. An internal memo from the Department of Armaments, sent to Speer's office in November 1944, warned, "The recurrence of the use of the M4 among our units shows a gap between technical discourse and operational reality." It was a veiled admission that the narrative had broken. There was no point in hiding it anymore. Even the enemy was using and preferring the tank they despised. The reasons were clear: mobility, ease of operation, reliability of the systems, lower weight and resistance to different terrains. But there was also a logistical factor. The Sherman was fed by abundant parts on the battlefield. German troops improvised maintenance using parts of destroyed tanks, many still intact in non-vital sectors. Some German campaign workshops even stocked Sherman parts as part of the regular inventory, knowing that they would soon be used. In technical terms, the Allied supply chain was unwittingly beginning to supply its own enemy. The situation became untenable for German pride, but it was impossible to ignore the results. The tank they called simple-minded had become the tactical trump card in retreat, rapid deployment, and infantry support missions. A weapon that did not impress on paper, but that persisted on the field. And when persistence begins to dictate war, window engineering loses its relevance. It was the beginning of the end of the doctrine of technical supremacy, because at that point, even the Reich soldier already knew reliability is worth more than raw power. But there was still one last blow to be struck against German industrial arrogance, and it would come not from a report but from a confession, a short, direct sentence written by an engineer who, in the face of the facts, could no longer lie. The mechanized warfare of World War II was won not only in the noise of the cannons, but in the repetitive, constant sound of the wakes that never stopped. And when one observes the mathematics that sustained this march, American superiority reveals itself in its crudest form. 49,234 units of the M4 Sherman produced between 1942 and 1945. A number so absolute that it alone exceeds the total production of all German tank models combined. Panther, Tiger, Panzer IV, Panzer III, Stug, Jagdpanther, Jagdtiger, and derivatives. Germany, with its doctrine based on absolute quality, has never prepared itself to face an avalanche of scale. But that's exactly what he found. While the Reich took days to repair a single Panther, 5 new Shermans landed in French ports, already fueled, calibrated, and ready for combat. The American front line remained fluid, because there was always a replacement ready. And where there is constant substitution, there is continuity. Where there is continuity, there is victory. The industrial supremacy of the United States was not limited to volume. She was in time. In 1944, a factory in Detroit was able to finish a Sherman every 28 minutes, with 4 shifts operating without breaks, 24 hours a day, 7 days a week. These machines were assembled with parts that came from hundreds of suppliers, spread across 48 states, all connected by an intact logistics infrastructure. Highways, railroads, ships, and convoys operating in sync, a feat that no nation at war has been able to replicate. Germany, on the other hand, saw its railway network crumble under the bombardments, its fuel depots emptied, its transport routes become traps. German tanks, even those leaving the factories, often never reached the front. Each Sherman built was not just a weapon, it was the embodiment of a functional system. The tank itself cost about $33,000 at the time, but behind it were entire factories of retrofitted aviation engines, converted steel mills, automated assembly lines, dedicated railway stations, spare parts warehouses, and above all, a technical doctrine geared towards the simple and the functional. The logic was clear. The tank didn't have to be a work of art. It needed to be reliable, inexpensive, and quick to replace. And the Americans followed this logic with clockwork precision. Not coincidentally, in June 1944, when the Allies landed in Normandy, more than 200 Shermans took part in the operation in the first 48 hours. Germany could never respond with that kind of number. For each Tiger I destroyed, intense logistics were required to replace it. Its production, of very high cost and complexity, generated a maximum of 25 units per month in stable periods. When factories were hit, that number plummeted. Sherman, on the other hand, even under adverse conditions, never failed to arrive. The front line was fed by trains, ships, and trucks that seemed to have no end, and even damaged tanks were sent back, repaired in record time, and returned to the field. The statistic is brutal. In 1944, the average operational availability rate of the Shermans was 78%. In some units, it exceeded 85%. By comparison, the Panthers operated at 30 to 45% availability on average, a functional breakdown that no ballistic advantage could compensate. Modern warfare, as the Germans would painfully learn, was no longer decided in isolated battles of tanks against tanks. It was decided by which army could be present day after day, with working machines, guaranteed fuel, ammunition in the compartment, and spare parts in the rear truck. It was decided by rhythm, and the United States was a rhythm powerhouse. Even the German generals recognized this truth. In a memorandum from Guderian dated October 1944, it reads, "The superiority of the enemy is not only due to the number of its armor, but to its ability to keep them operational every new day." The phrase is revealing. It is not about bravery. It is not about bravery or refined tactics. It's about being there, always. While German engineers wrangled over details of torque, cylinder pressure, and ballistic penetration, the Americans adjusted schedules, optimized transportation, and doubled production. The Sherman's maintenance manuals were simple, illustrated, and available in several languages. The tank could be dismantled in the field, repaired with basic tools, and returned to combat within hours. A battalion of engineers was not needed. All that was needed was will and parts. And these pieces came incessantly. The psychological impact of this advantage was devastating. While a column of Panthers could break up in a forced march of 80 kilometers, a platoon of Shermans covered 300 kilometers in 2 days, with minimal maintenance. War, once a duel of concepts, became a game of presence. And in that game, Sherman had no rival. If this surprises you, comment, "Logistics wins." Because that's the most painful truth Germany has discovered. It's not about who has the best tank, but who can keep it running longer, in more places, more often. With every Panther burned, every Tiger jammed, every Jag Tiger abandoned for lack of fuel, more Shermans arrived, and more, and more. The war turned a tide, and this tide had a name, serial number, and noisy wakes that advanced even under heavy fire. But this avalanche still had a face, a man, because in the midst of thousands of tanks, there was a German engineer who saw everything, recorded everything, and in the end admitted the impossible. A sentence written in 1945 by hand in a report that would never be published by the Reich. A phrase that would overthrow the last resistance of German technical pride. The final revelation came not from a battlefield, nor from a public test, but from the silent pages that rested within Kummersdorf's technical archives, meticulous reports written by engineers who had dedicated their lives to German precision and who now found themselves facing a machine that contradicted everything they believed. These documents, many of which remained hidden during the war, reveal that the technicians did not just study the Sherman, they understood him deeply, and to understand meant admitting that their own paradigm had failed. On the very first pages, terms appeared that would never appear in any official bulletin: exceptional reliability, high industrial tolerance, suitable for extended operations. Germany, accustomed to designing machines that operated at the limit, discovered here a vehicle that simply did not require genius to function. It required mass production, consistent metrics, and an industrial philosophy that the Reich never mastered. The irony of this story is that the solution was in front of them. Sherman showed how American standardization turned complexity into efficiency. If you're enjoying unraveling these facts, show your support. Like and subscribe so we can bring you more in-depth content. One of the most damning reports described the M4 transmission as exemplary in functional simplicity, an expression that for German engineering amounted to a confession. Another document evaluated the Continental R975 engine as suitable for prolonged military use without the need for specialized maintenance, contrasting with the Maybach, which required constant adjustments. In personal notes, a Waffenamt engineer wrote, "American standardization results in performance that exceeds what our shops can deliver." It was not a compliment, it was a statement. And page after page, these conclusions were repeated. They measured the lifespan of the engines. They compared bearing wear. They tested the air filtration. The result always led to the same point. The Sherman operated under conditions that destroyed Panthers and Tigers. German engineering, in its quest for absolute perfection, had ignored what underpinned mechanized warfare, durability. But the most devastating admission was in a 1944 internal memo found after the war in the Kummersdorf archives. "We do not possess the industrial capacity necessary to replicate the American model of reliability." It was the first time that the German technical staff acknowledged in formal words that their defeat was not only military, it was industrial. They could not match the logic of American production. They could not train thousands of highly specialized mechanics. They could not produce tanks that tolerated imperfections. German engineering had turned into an overfounded colossus, brilliant but fragile. The Sherman, on the other hand, accepted the world as it was: dust, mud, heat, winter, and kept on rolling. In personal diaries, engineers reported their surprise at disassembling the M4's powertrain. They hoped to find improvisation, found robustness. They expected carelessness, found method. One wrote, "Americans build as if the camp decides. We build it as if the workshop decided." This philosophical distinction defined all armored warfare, because in the countryside, far from factories and technicians, what mattered was the tank that started in the morning and still worked at dusk. Sherman did that, not Panther. This understanding was too painful to admit publicly, but within the reports it became impossible to ignore. There were tables, graphs, measurements, photographs. There was proof, and the evidence destroyed the myth of German technical superiority. The engineers learned more than they would like to admit. They absorbed American principles such as full interchangeability, flexible industrial tolerances, and simplified maintenance methods. These concepts, which had previously seemed almost heresy to the German school, became essential in the post-war period. When West Germany began development of the Leopard 1, the designers worked with the lessons of the Sherman in mind. The new tank was to be light, reliable, easy to maintain, and quick to produce. American principles finally transformed into German doctrine. Sherman's legacy would live on inside the Leopard, a machine that would become a world reference. But the final blow was yet to come. In a note dated February 1945, one of the engineers, already aware that the war was lost, wrote a short, almost desperate sentence. "We build tanks to win battles. They built tanks to win the war." And this recognition not only ended the debate, it revealed the essence of the German defeat. Because Sherman had shown, piece by piece, report by report, that modern warfare was not about perfection. It was about continuous presence, relentless repetition, overwhelming industrial strength. And if the internal reports had revealed the technical truth, the practical reality would begin, that same year, to destroy the last myth that remained, that Germany could still make up for its losses in the field. Because what came next showed that not even the tanks that arrived at the front were free from the mechanical bankruptcy that corroded the entire German armored doctrine. In 1955, 10 years after the end of the war, West Germany founded its new armed force, the Bundeswehr. Born under the shadow of a military and moral defeat, this new institution needed more than weapons. It needed doctrine. And curiously, part of this doctrine would come from a tank that, during the conflict, had been underestimated, tested, dismantled, and in the end, admired. The M4 Sherman, the symbol of brutal American efficiency, became, unknowingly, the silent tutor of the new German armored engineering. The engineers who survived the collapse of the Reich Many of them, the same ones who tested the Sherman at Kummersdorf, went on to occupy strategic positions in the technical commissions of the Bundeswehr. And along with the reconstruction, there was also the memory. There was a pattern that worked, and this standard was not German, he was American. During the development of the Leopard 1, launched in the 1960s as the first tank in the new Germany, three principles guided the project: reliability, ease of maintenance, and adaptability. None of these pillars came from the Panther or the Tiger. They came directly from Kummersdorf's forgotten reports. The new German tank could no longer be a work of art. It had to be a workhorse. The Leopard 1 prioritized mobility over extreme armor. Its engine was designed to last hundreds of hours with minimal maintenance. Its internal systems were designed with interchangeability, and more than anything, the doctrine that accompanied it did not require genius operators. It required well-trained soldiers, as in the American model. In short, Germany, which had once built tanks like steel sculptures, now embraced practicality. This transition was no coincidence. Internal documents of the Bundeswehr Armaments Commission reveal that engineers such as Karl Mertens, Friedrich Rabe, and Otto Kretschmer, who were linked to the technical sector of the Wehrmacht, explicitly recommended a review of the tests carried out with the Sherman. One wrote, "The concept of American maintenance must be the basis for our next combat platforms." That recommendation, while never mentioning the name Sherman publicly, was a direct nod to the tank they had tested, resisted praising, but had understood. The Sherman's influence also extended to technical details. The Leopard 1's suspension followed a simplified high-strength model, much closer to American philosophy than to the interspersed suspension of German tanks of the war. The same was true of the interior layout, the centralization of controls, and the quick maintenance points, all reflecting engineering focused on the field, not on theory. The admission of this change in mentality, however, was never made out loud. It would be politically unacceptable to acknowledge that the revival of German military engineering had been born out of the analysis of an enemy tank. But the facts speak for themselves. The Leopard 1 became one of the most reliable tanks of the 20th century, exported to more than a dozen countries, with an operating rate that often exceeded 90%. It was everything that the Tiger was not, everything that Panther tried to be, and everything that Sherman already was. The master in this case was not the most sophisticated, he was the most constant. The technical legacy of the M4, despised at the time, was now echoed in NATO's arsenals. The most surprising thing is that this influence was not restricted to Germany. Several countries that participated in European reconstruction, such as Italy, Belgium, the Netherlands, and even France, re-evaluated their concepts of military engineering after the war and adopted philosophies close to the American one. The Sherman, which operated in dozens of countries even after 1945, became a symbol of a new era, the era of the utility tank. The tank that didn't have to be the best, it had to be there. This lesson, absorbed slowly, shaped the MBTs of the following decades, and for Germany, it represented a break with the very technical pride that had cost it its ability to adapt. Bundeswehr modernization reports in the 1970s clearly show American influence on armor maintenance and doctrine. Field workshops were standardized, manuals became simplified, and the requirement for highly specialized operators was eliminated. In their place, platforms with user-friendly interfaces and modular systems have entered. It was Sherman, disguised under a new name, a tank that taught with each kilometer driven that reliability was more powerful than genius. That success in war came from repetition, of constancy, from the tank that just arrived. This part of the story is rarely told because it doesn't involve heroes, epic battles, or brilliant strategies. It involves gears, bolts, technical reports, and industrial decisions. But it is in this silence that the war, in fact, was won. When American tanks crossed Europe, it was not just the advance of a military front. It was the triumph of logic, of a mentality, of a system that preferred function to form, and that, when tested even by enemies, showed that there is more intelligence in repetition than in exception. Now, what is perhaps most impressive about this chain of events is not that Sherman taught anything. Even after the war, it continued to be used and adapted in dozens of conflicts around the world. From the Sinai Desert to the forests of Latin America, it has not disappeared. He has evolved, which brings us to the final question. What does this tank, so often underestimated, still have to teach about how to win a war? Because there is one last statistic buried in the archives of history that can reveal the full impact of its existence. A statistic that does not speak of cannons, but of decades. The tests at Kummersdorf were recorded, analyzed, and archived with near-scientific precision. The reports existed, the graphs were complete, the observations were clear. The Sherman, by all measurable parameters, had exceeded German expectations and defied the doctrine that guided its war engineering. But this conclusion has never been publicly pronounced. No Wehrmacht general, no armaments minister, no official bulletin admitted what the technical documents could no longer hide. Silence was the only institutional response to the doctrinal defeat imposed by a tank built by American civilians. The reason was simple: to admit that the enemy had won not only on the battlefield, but also in the field of engineering, meant to break with the very myth of German superiority, a myth vital to sustaining the collapsing morale and propaganda of a war that was already proving unsustainable. Goebbels's propaganda ministry never allowed Kummersdorf's data to circulate. Instead, the discourse was maintained that German tanks were the most powerful in the world, that Panzers, Tigers, and Panthers symbolized the technical invincibility of the Reich. The Sherman tests were classified as secondary studies, and their results were systematically disregarded in armament decisions. Behind the scenes, however, engineers and technical officers recognized the gravity of what they had witnessed. Internal memos, now rescued by historians, reveal a growing discomfort with the official narrative. A Waffenamt colonel wrote, "If the war were decided by mechanical resistance, we would have been defeated months ago." Another engineer, in a personal note, noted, "We built tanks to parade. They built tanks to survive." But these outbursts remained buried in archives that would only come to light decades later. The reason for this silence was not just pride, it was political survival. In a crumbling Germany, where the military hierarchy was sustained by absolute loyalty and discipline, contradicting the official narrative was almost an act of treason. Kummersdorf's engineers knew that their reports would never be read by Hitler, and if they were, they wouldn't be taken seriously. The Führer had lost confidence in his own experts since Stalingrad. He preferred fantasy to technical data. He preferred to believe that the next supertank, the next secret weapon, would change the course of the war. The Sherman, with its simple frame and noisy engine, was everything Hitler despised, and, ironically, everything Germany needed. But the Reich was no longer able to accept inconvenient truths. Still, outside Germany, the Sherman's reputation grew. After the end of the conflict, British and American researchers had access to part of the German technical archives. Upon reading Kummersdorf's reports, they were surprised by the technical honesty and detail of the data. A researcher at the Royal Armoured Corps wrote, "They knew, they just couldn't say." This realization began a series of comparative studies in the post-war period, many of which reinforced Sherman's image, not as a lone hero, but as a reliable pillar of the Allied war machine. Books, articles, and academic theses began to highlight not only the tactical performance of the M4, but its strategic importance, as a symbol of the war of attrition won not by the genius of a designer, but by the constancy of a production line. The contrast between what the Germans knew and what they said highlights one of the great contradictions of modern warfare: the distance between technical truth and political discourse. In times of conflict, admitting structural flaws is not only risky, it is unthinkable. Therefore, the Panthers' defeat against Sherman never made headlines in Berlin. For this reason, the engineers of Kummersdorf were never interviewed. Germany's deepest defeat was not in the trenches, it was in the silences. And in those silences, history revealed itself with a precision more cruel than any cannon. Because the enemy they thought was inferior had taught a lesson that not even the toughest armored vehicle could ignore. Reliability is the true name of the force. This distance between what was known behind the scenes and what was propagated to the public was not exclusive to Nazi Germany. In every war there are official versions, inflated numbers, amplified victories. But Sherman's case is peculiar. Because he didn't win because he was invisible or because he had some secret weapon. He won in plain sight. And yet it was ignored, ridiculed, underrated. This makes it even more powerful as a historical symbol. The tank that no one took seriously, but that was present in all fields, on all fronts, at all times. The tank that didn't break, that it did not fail, that he did not need justifications. The impact of this silence still reverberates. For decades, the Panther and Tiger have been deified by enthusiasts, by movies and by books that extolled their power. Meanwhile, the Sherman was described as inferior, fragile, almost disposable. But the technical reports don't lie. History, when told with data, reveals an inverse narrative. Tanks that seemed invincible were, in practice, unsustainable, and the tank that seemed weak was actually the foundation on which the victory was built. Today, military historians recognize this narrative imbalance. Work by experts such as Stephen Zaloga, Harry Yide, and Belton Cooper helps to reposition the Sherman within its proper context, not as a technological marvel, but as the smartest solution to a real problem. A tank that understood war as it is, long, dirty, unpredictable, and that, for this very reason, it won. But there is one last confession. It didn't come from an engineer. It came from a commander. And it was not written during the war, but many years later, in an essay published in West Germany. He wrote, "If we had learned from that tank, we might have lasted longer, but pride prevented us from listening to what he was trying to tell us." This phrase, simple and devastating, sums up not only the history of the Sherman, but the complete bankruptcy of German technical doctrine. Because in the end, it wasn't the armored vehicles that collapsed. It was the belief that genius would win a war of attrition. And while this confession is lost in specialist books, there is one last, even more symbolic detail that needs to be revealed. A number, a fact that never made it into the speeches, but which may seal once and for all the real impact of the Sherman in World War II. The M4 Sherman has never been admired for its design. It did not cause panic from a distance. It didn't carry the mysticism of the Tiger, nor the grandeur of the Panther. It was, in essence, a functional tank. No ornaments, no exaggerations, no impossible promises. But this simplicity hid, for a long time, one of the greatest virtues that a war machine can have. It worked. When the engines needed to spin, it turned. When it was necessary to cross a river, climb a slope, resist the heat, the mud, the ice, he was there, always ready, always available. It was the tank that arrived. This constancy became the Allies' greatest weapon. Instead of relying on the luck of a perfect design, the United States relied on the consistency of a good enough design, produced thousands of times. And this decision revealed a philosophy of war radically different from German doctrine. While the Reich tried to win with genius prototypes and isolated ingenuity, the Americans bet on an almost obstinate logic of standardization, logistics, and predictability. To the German engineers, this was heresy. But for the commanders on the field, that was all that mattered. The Sherman was reliable not only because its parts were good, but because the entire system around it worked. Mobile workshops, parts inventory, simple repair manuals, standardized training. An American tank could be destroyed, and in a few hours another like it would take its place. For every Panther that arrived at the front, the Americans brought 5 Shermans. For every overheated engine Tiger waiting for rare parts, there were dozens of M4s fueled, operating, fighting. The victory did not come from a mechanical duel. It came from an industrial philosophy. This philosophy was based on a clear idea. The tank is not an end in itself. It is a tool. And like any tool, its main function is not to impress, it is to work. Sherman embodied this logic perfectly. He did not win by the force of a single shot. It won by its continuous presence, operational resistance, and ability to maintain pressure. It was the total war tank, where every second, every kilometer, every piece changed at the right time, counted. Unlike German designs, which required specialized pilots and maintenance by trained engineers, the Sherman was operated by ordinary soldiers. Its internal structure allowed quick access to the main systems. Its engine could be changed in the field. Its turret could be rotated manually if necessary. There was no secret. There was clarity, and that clarity saved lives and won battles. While the German tanks stalled for excess complexity, the Shermans forged ahead with the simplicity of a hammer. This engineering choice was not just technical. It was in essence an ethical choice, a choice to protect the operator, facilitate the repair, ensure that the soldier would have something to fight with the next day. This is where the story goes deeper, because reliability, when taken to the extreme, is no longer just a technical specification. It becomes a moral value. The Sherman carried this amount, and that's why, even without causing an aesthetic impact, even though it was ridiculed by armored enthusiasts, it was the tank that changed the course of the war. This view becomes even clearer when we examine the availability rate in the field. In 1944, in the midst of the Normandy campaign, the Sherman maintained an average of 78% operational availability. This means that out of every 10 tanks, almost 8 were ready to fight, every day. In contrast, the Panthers, even fresh off the assembly line, rarely exceeded 40% availability. The Tiger, with its handmade pieces and excessive weight, reached 30%. This is not a statistic. That's a death sentence for any army. This is the moment when many viewers are surprised. After all, for decades, the image sold was the opposite. German tanks as unbeatable legends, and the Sherman as a secondary vehicle. But the numbers tell another story. If this reality surprised you, leave a sentence in the comments that captures the impact of this finding. Something like shocking data or logistics wins, because that's exactly what it is. The war wasn't won by a duel of brute force, but by a system that guaranteed a continuous presence on the battlefield. But there is still a more subtle layer to this story. The Sherman wasn't just the tank that worked, it was the tank that taught. When analyzed by German engineers, it challenged central assumptions about what an ideal war machine was. When used by soldiers on different fronts, British, Soviet, French, captured Germans, it showed that its effectiveness was universal. It was adaptable, replicable, understandable. And in the post-war period, as we have already explored, it became the indirect basis of a new generation of European armor. What does this tank tell us then? That in times of war, the noblest choice a designer can make is not to create the most powerful, it is to create the most constant. That true power is not in rarity, it is in reliable repetition, and that the beauty of a machine is not in the polished metal, but in the confidence it inspires. The Sherman was that kind of machine, a silent colossus, a warrior without ego, a tank that didn't need to impress to win. And this lesson does not end in the 40s. It echoes to this day in military doctrines, in philosophies of production, in cost-benefit analyses. The world has learned, often too late, that reliability is the last line between success and collapse, and that, when all else fails, those who are still present win, always, like Sherman. But one last image is missing. One last scene that would forever seal the meaning of this tank, not in reports, not in statistics, but in the reaction of the enemy himself when he sees him operate, the final confession, the phrase that sums it all up, and that to this day carries the weight of a truth that not even time has been able to bury. By the time the German engineers finally closed Kummersdorf's reports, the Reich could no longer sustain the illusion of technical superiority that had fueled its doctrine since 1939. The truth that emerged from the pages was unmistakable. The collapse was not caused by a lack of genius, but by an excess of it, applied in the wrong place, at the wrong time, with resources that Germany no longer had. The Panther, the Tiger, the Ferdinand, they all represented the pinnacle of an engineering that refused to accept the country's industrial limit. The Sherman, on the contrary, represented the total acceptance of this limit, transformed into strength. With every gear that didn't break, with every engine that didn't warm up, the M4 made clear the disconnect between German ambition and its real capability. The decisive military defeat didn't just come from the Normandy, Italy, or Ukraine fronts. It was born in the German warehouses themselves, on the tracks where Panthers were towed back to factories, in the warehouses where Tigers waited for parts that would never arrive, in the fields where exhausted mechanics tried to make up for what should have been solved in the project. When the Reich finally collapsed in 1945, it had already been beaten years earlier in the quiet mathematics that Sherman laid out. The universal lesson of this story imposes itself effortlessly. Modern wars are not won by the most impressive machine, but by the machine that runs every day. Brilliant strategies, impeccable commanders, revolutionary weapons, none of this survives without a rearguard to bear the brunt of friction. Logistics decides survival before heroism can decide victory. Engineering that favors the common soldier triumphs over that which requires rare specialists. And above all, the industry always wins the battlefield. This is the bitter truth that the Kummersdorf engineers learned too late. Reliability is not just a technical requirement, but a direct equivalence of national power. It is the bridge between theory and survival, between the project and the real war, between what an army appears to be and what it really is. Not by chance, the most forceful final admission came years later, in silence, when there was no more propaganda to sustain. An old German officer summed it all up with a phrase that spanned generations. "We were defeated by trucks, and by a tank that never stopped." This sentence not only closes the story, it opens your eyes to its real magnitude. So if this detailed research and deep dive into the technical backstage of the war has added anything to your understanding of history, support this work. Leave your like and subscribe to the channel to strengthen our ongoing search for historical truth. And record in the comments what was the most shocking data for you, whether it was the 2,000 kilometers of the Sherman without heavy maintenance, the 49,000 tanks produced by the United States, or the German availability rate plummeting to less than 40%. Ring the bell so you don't miss the next devastating historical fact that has challenged myths, egos, and narratives. And before you leave, remember, every war hides its true story not in the heroes but in the numbers and in the mechanical details that few care to observe. Don't go away yet. Listen to the next real story that will appear on the screen. Always remember, logistics determines strategy. Watch the next video here on the channel with another incredible story and keep unraveling with us how the war behind the smoke and noise is decided by gears, margins of tolerance, and the simple fact that one machine keeps running when all the others give up.